All right, so on Monday, we started solving systems of equations. Yay. So this is like back to Algebra 2 and Algebra 1. It's all coming back. We started solving systems of equations. So remember a system of equations when you have two equations and you're trying to find the x and the y that works for both of them. And we primarily talked about these two methods, which is substitution and graphing. So Greta, that's what you missed. You missed some fun graphing and substitution discussions. One thing to note, Greta, when you're doing your homework, like if it, for example, it says, yeah, I know. It says solve the system graphically, verify your solution algebraically. That can be like a quick check. So you don't have to, like in your homework, there's a lot of problems to do. So you don't need to like write out the whole algebraic proof for that. If you kind of can plop in a number or two, or, it can be a quick check, I guess. It doesn't have to be a full, like, well written out check, if that makes sense. All right. Yes. I mean, you can do it all the way written out check if you would like. I don't want to stop you. But, all right. So then, the second section that we talked about is 7.2, which is solve systems of linear equations by elimination method. So for the elimination method, remember, we're going to get rid of one of the variables in order to solve the other one. So we did an example or two of this, but I want to do a few more examples of this, even though it might be kind of easy. I just want to make sure everybody's on the same page for this method. And then that might be all I do this week because I don't want to, I think we need to wait for this one until Monday when we're all together. This is when you have X, Y, and Z, and you're solving for all three of them, right? Okay, so what I'd like to do is maybe do, I know we did number 2. Let's do one that I've done before so that if I mess up, I'm like, okay. Let's see where you're at. There we go. Let's do number 14. Let's do number 14. Zoom in a little bit. So again, we're solving systems of linear equations. We have multiple methods to solve them. So we might even do this one multiple ways because everybody loves it when you do a problem more than once. Hey, Connor, how are you? Okay, so we've got 3u plus 11v equals 4, and we have negative 2u minus 5v equals 9. And the directions, I should have read the directions. They said, in exercises 7 through 16, solve the system by the method of elimination and check your solutions algebraically. Okay, so elimination means that we're going to get rid of one of the variables by making it the same as the other one. All right, so in a really simple example, if you had a positive x and a negative x in two different equations, you add them together and they get rid of each other. This is a little bit more complicated, right? But we can totally do it. So if I was looking at this equation, I noticed, first of all, it's tiny, but if I looked at this, I noticed that in the top, I have a 3u, and the bottom, I have a negative 2u. So if I can make the coefficient the same, when I add them together, we have a positive plus a negative, so they'll cancel each other out. So that kind of gives me an idea that if I can make the front coefficient 3 and 2 the same, then maybe I would have an easy time canceling out. So what I'm thinking is that I'm going to multiply my whole top equation by 2. Okay, so what I mean by that is I'm going to do 2 times 3u plus 11v equals 2 times 4. All right, so my top equation is going to become, I like it when we can leave this on one line. My top equation is going to transform into 6u plus 22v equals 8. That's my top equation. All right, so if I transform the top and make it 6u, I want to make the bottom u also equal to 6u. I can circle the bottom u also equal to 6u. So I want to multiply the bottom by 3. Okay, so I want to do 3 times negative 2u. I think it's plus 5v, yeah. Plus 5v. Nope, it's minus 5v. Good thing I checked that, because that would be not good. Minus 5v equals 3 times 9. So my bottom equation becomes negative 6u minus 15v equals 3 times 9 is 27. Okay. So when I do that, now I can add my two equations together and I cancel out the u's. I have 6u plus negative 6u, and so that goes away. And I'm left with 22v minus 15v, which is 7v. And 27 plus 8, which is 35. And that makes me happy because I know that 35 divided by 7 is 5, and I always like it when you get a nice even number, right? So we know v equals 5. So then I need to figure out what u is. I figure out u by picking one of the equations and plugging v in. It doesn't matter which one. I'm going to go for the top one just because why not? So I have 3 times u plus 11 times 5 equals 4. Okay. 3u plus 55 equals 4. Subtract 55 from both sides. And I get 3u equals negative 51. Don't love that number, but all right. It does divide by 3 because 5 plus 1 is 6 divided by 3. So u equals negative 17. So my solution to this is negative 17, 5. Right? So then if I was going to check my answer, it says check it algebraically, but I'm just going to say check it somehow. The easiest way for me to check it would be not my email, but Desmos, right? So I just need to plug in my original equations and find out where they meet after Desmos loads. Okay, so I have 3. I don't know if I do u and v, what it'll do. No, it doesn't like that. So you got to change them out for x and y. 3u plus 11v equals 4, right? And I have negative 2u minus 5v equals 9. So I know I'm saying v and u, but you have to change them out for x and y. Desmos isn't that smart yet. Okay, so they should intersect theoretically. We found the point to be negative 17.5. So hopefully, there we go, negative 17.5. Whoop, whoop. Okay. Everybody feel comfortable doing that? That's the elimination method. Now, if I asked you to solve this by substitution or graphing, could you do that? Could you solve it by graphing?
Yeah.
Yeah. Could you solve it by substitution?
Yeah.
You good? All right. Greta and Mackenzie, can you solve it by substitution, or do you want me to? Do you want to see that? Probably.
Yeah, I can.
Okay. Just, well, Greta, because you were sick on Monday, I'm not going to do the whole thing, but what you would do, remember if this, so this is elimination, what we just did, right? substitution, let's see if I can sneak it in here, means that you're going to solve one of these for one variable. So if I have negative 2u minus 5v equals 9, none of these are great to solve for. Maybe let's solve for u, right? So I get negative 2u equals 5v plus 9, and then I divide everything by negative 2. So I get u equals 5v plus 9 divided by negative 2. And then I take this is my second equation, and I plug it into my first equation for u. And then that's going to get rid of all my u's. I'm going to be left with v. So that's how you would solve that. Okay. Let's do at least one or two more. Okay, yes. Yeah, Greta back from Algebra 2, exactly. Substitution, elimination, graphing, all from Algebra 2. Making a comeback, right? Okay. So, just a reminder, let's do number. So it says in 17 through 20. So you don't have much homework in here, by the way. It's 1 through 15 odd. And then 17 through 20. So it's not like I'm giving you a million problems. But let's look at 17 through 20. So you're kind of getting a head start on your homework. It says in these exercises, match the system of linear equations with its graph, state the number of solutions, then state whether the system is consistent or inconsistent. And then the graphs are labeled A, B, C, or D. Okay, so kind of doing homework on the call here. Okay, so let's do number, let's do these all pretty quick. Let's do 17 first. Okay, so number 17 is, actually, let's do 19 first. 19 is 2x minus 5y equals 0, and 2x minus 3y equals negative 4. Okay, so when you see this, you're excited because you don't have to do anything to do elimination because you have a 2x and a 2x. So as long as you subtract them, they cancel each other out. I always like to make one of them negative and add together because in my mind that's easier. But if you want to just subtract them, go for it. So what I mean by making everything negative is I'm going to multiply everything in this one by negative 1. So then this becomes negative 2x plus 5y, and then negative 1 times 0 is just 0. So that means I get to add them together and I don't have to worry about things. So negative 2x plus 2x is nothing. 5y minus 3y is 2y. And 0 plus negative 4 is negative 4. So y equals negative 2. So then to figure out x, right, I do 2x minus 5 times y, which is negative 2, equals 0. So 2x plus 10 equals, sorry, I was thinking in my head the answer is 0. So 2x equals negative 10, or x equals negative 5. So which of these graphs show a solution at negative 5, negative 2? Let's see. Looks like C is our winner, right? That's negative 5, negative 2 is the answer to number 19. So that's not too bad. So we would call this a consistent. So one of the things says state whether the system is consistent or inconsistent. We would call this a consistent system because we know what the solution is going to be. So it's considered consistent. Okay. All right. So Can you look at these graphs? You see these two, A and D. One of these graphs is not going to work, right? So let's look at number 20. Number 20. We have 7x minus 6y equals negative 6, and we have negative 7x plus 6y equals negative 4. All right, happy dance. I don't even have to do anything. I just add them together, right? 7x plus negative 7x is 0. Negative 6y plus 6y is also 0. But when I add these together, I get 0 equals negative 10. Is that possible? Can 0 equal negative 10? Nope, 0 can't equal negative 10. Maybe in some alternate universe. So what does this look like when you graph it? Number 20 is going to look like D, right? They're two lines, but they never intersect each other. So we would call this an inconsistent system because we don't have anything. So that's kind of the new word. We would, in Algebra 2, we'd say there was no solution. And now you can say that it's inconsistent because we don't have this constant solution. Okay. What do you know about A, graph A, without even looking at the equations? There's only one line. What do you think that means? So when there's only one line like that, that means that there's infinitely many solutions, right? That means that we can have anything along the line is true. So let's check number 18 and see what that gives us. So we have negative 7x plus 6y equals negative 4. And we have 14x minus 12y equals 8. Okay, so we're going to solve this by elimination. We're going to need to do a little work. Let's multiply the top by 2. By 2. So then the top one becomes negative 14x plus 12y minus 8. Okay, if I add these together, 14x plus negative 14x is 0. Negative 12y plus positive 12y is 0. And 8 plus negative 8 equals 0. So it looks an awfully like this one, right? But this one, 0 does equal 0. That's true. So when we get that case, that means that we have infinitely many solutions. So number 18 would be A, and we would also call that consistent because we do have solutions. Okay. All right, so then I think you guys can figure out which one number 2 belongs to. I think that's all I want to do for today because I don't want to overwhelm you with 7.3. I know that you guys have chapter 8 to finish up, so get your chapter 8 finished up and start working on these two because I will give you a little heads up. 7.3 is like a little bit of a monster. So get everything finished up so that next week you can start fresh with 7.3. Just to give you a little heads up, this is when we have 3 equations and 3 variables. So we have the methods of elimination and substitution that we used to do back in Algebra 2. And I'm going to teach you some other methods to solve these. There's one called Gaussian elimination that I'm going to teach you how to solve these. But they are kind of like big clunky problems. So I would encourage you to get, well, you definitely have to get all your chapter 6 stuff done. And I would encourage you to get 7.1 and 7.2 done this week, so that next week when we start 7.3, it doesn't seem so like, ugh, right? Does that sound good? So use the next 25 minutes to go do your homework. All right, guys. Thanks for coming today. All right. Have a good rest of your day. Let me know if you guys have any questions on chapter 6. All right.
Thanks. See you Monday.
Thanks. See you Monday. Bye.